number 11, I got y equals square root x, y equals 0, x equals 3. Right?
Yeah.
Those are my functions. Okay? So 0, 0, 1, 1, it'd be 4, 2. I'm going to stop it right there. So there's my region, correct? I got y equals square root of x, y equals 0, x equals 3. That would be my enclosed region. Just for our purpose, that would be 3 comma square root of 3 right there, right? That coordinate. Are you with me on that? Okay. All right. In part A, they simply want us to rotate it 360 degrees around the x-axis. Okay, that's an easy one, right? You'll just use your common disk method because it's solid to the x-axis. Let's just set it up. I'll save that for you to actually do, but let's just go ahead and set it up. What will it be? Pi times the integral. 0 to 3. Because we're not doing up and down, right?
Yeah, I know. She said 0. Yeah.
Oh, okay.
X squared squared.
Square root of x squared.
Square root of x squared dx. Okay?
Yeah.
Okay? So that simple one. Okay? Because the region is solid to our axis of revolution, you don't need to worry about any sort of washer method or anything like that. Okay? It's just a solid disk all the way through.
Yep.
Okay? All right. B is the y-axis.
Do we have to read
I'm going to because it helps.
Oh, come on.
Okay, now, if I take this solid and I rotate it around the y, you'll really end up with something like this then over here as well, right? Except it'll be that
Full.
circular solid, right? But if you were looking at it, that's what it might, that would be your cross section of it if you were to like cut it. Okay, yeah. Okay. That's what it would look like after you rotate around and then slice it down the middle. Okay. So since we're rotating it about the y-axis, you know you're going to have to write it in terms of y. Right? Okay. Pi times the antiderivative from where to where?
0 to square root of 3.
This one is 0 to square root of 3. Yep, because in the y direction, 0 up to the square root of 3 there. That's
How
that.
did we get the square root of 3 again? Yeah, back here.
Because I knew that my limit here in the x direction was x equals 3. So if I want to know what coordinate this is right here, I know my x value is 3, right? Well, isn't this the function y equals square root of x? So if my x value is 3 and I want to know what the y value is there, I could just plug 3 in for x. And when you
Yeah,
plug...
I just did.
Yep, that's all right. Okay. So I'm going from 0 to the square root of 3. Okay. Now, the radius of each cylinder, if you will, okay, or maybe the better way to think of it well, yeah, we can think of this using the washer method, okay? Because our region does not touch the y-axis, there's a gap in there, creating kind of a washer method idea, okay? So what I would do is I would pretend it was solid, find that solid volume, and subtract this part out of it. Yes, no?
What do you mean?
So just
Why can't
wash
we do
the
it the
formula?
other way?
Because the region that we're rotating is not right up next to the y-axis. The axis of revolution is not being, it's not solid around that.
I thought it goes to the y-axis then. Does it not?
So if this was our enclosed region and we rotated it around,
Yes. Are you saying there'd be a hole?
well, kind of, like,
There's an open
Yeah,
space.
Yeah, I get that.
okay.
Oh, okay. Yeah.
So what we do is we try to envision this really skinny cylinder,
Yeah.
okay, that would be created by taking,
But since there's a gap in the middle of that
I
cylinder,
didn't mean to, I'm sorry.
I get you now.
yep, okay,
I thought you were saying there was like this dip and then there was a hole in the middle of the dip and that didn't
Mhm,
make sense.
mhm.
I get you now.
so what I guess I'm thinking about doing is I'm pretending it was full, like it was just a solid rectangle right here.
Yep.
And so that function would be just simply x equals 3. Okay? So 3 squared dy. That would give me, if it were a solid disk all the way through, that would give me the entire thing. So in other words, I don't want to do this here,
Just
but
use another color.
I would enclose this, shade it all in, and that's what it would end up making. Then I want to subtract out that part, rotated. I want to find the volume as if it were complete and subtract out that volume right there. Okay? So
Like
it'd be there.
a y-axis walk.
Way there.
Okay? So minus pi square root of 3. Well, let's say this was our shaded region right in here, this open white region right here. Let's say we wanted to find just the volume of that.
You take the whole and then subtract
Well,
it.
what is this function here in terms of y? If we have y equals the square root of x, then what would x equal?
Y squared.
Y squared.
Y squared. So this is taking like multiple concepts and putting it in one problem.
Mm-hmm.
Which is why we're doing it now and not earlier.
Not later.
Okay?
It's taking multiple concepts that we've already done, we're doing it now instead of before we learned those multiple
To
concepts.
get your Luke gauge.
That's what I said before.
All right.
Yeah, that's just.
So that's the setup for the purpose of
Where
it.
do we get the root
All right. So go. What?
from? Where do we get the root from?
Yeah.
So what I'm pretending first here is that I'm taking
That entire section.
that entire section and rotating it around the x-axis. Or excuse me, the y-axis.
But you didn't go up 3, you went over 3,
Because you're going up y-axis.
right?
Would it, okay, envision this rotated around in that cylinder that is created. What is the radius of that cylinder?
3.
3.
Got it.
The radius of that cylinder rotated around would be 3. That's where this 3 is coming from, because this is your pi r squared h. This is your r. This is your radius. Then I'm going to subtract out that part, rotated around. And what is the radius at each y value? Y squared. Okay? Because the y values here are equal to the square root of x, so the x values are equal to y squared. For instance, I'll use this coordinate. Well, it's maybe not good because they're both 1s. Okay, but the radius is 1 because if my x value is 1, my 1 squared would be 1. Let me maybe use, if my x value was 1.5,
Make
I
sure
don't
it
know.
works.
I don't know the square root of 1.5. It's 1 point do something or other. I can't do that math.
We get what you're saying.
So I'm finding the volume of this rotated minus the volume of that rotated.
Would there be an easier way to do this?
Nope.
No.
Calculus is a no.
Okay?